In this lecture, we are going to learn about the transpose of a given matrix. So first of all, we are going to find out or devise our own logic for actually finding the transpose of a given matrix. And then we are going to write a computer program to demonstrate the same. And then we are going to learn how we can pass a 2D array to a function. Okay, so let's get started. So first of all, what do you think is a transpose of a matrix? So given a matrix can be any rectangular matrix. It can also be a square matrix. Given a matrix, how do you find the transpose of a matrix? It's very simple. What you do is you will actually interchange the row into column, or you interchange the column into the row. That's very simple, right? Let's look at this example wherein a matrix A is given, which is a square matrix of dimension 3 cross 3. Now how do I find the transpose of this matrix? Let's say T is the transpose of the matrix A, right? So in this case, what we do is we actually take the row and then place it in the column. Okay, if you look at the first row of the matrix A, you will find 1, 2, 3. So you will just catch hold of these three values 1, 2 and 3 and place in the first column of the transpose matrix. So here you will get 1, here you will get 2 and here you will get 3. So the row of the original matrix, the first row, becomes the first column of the transpose matrix. Now you move to the second row of the original matrix, that is 4, 5, 6, and put it in the second column of the transpose matrix. So it will be 4, 5, 6. That means I am catching hold of the row and putting in the column. Now finally we'll catch hold of the last row of the matrix A, that is 7, 8, 9, and paste it here in the transpose matrix in the last column, that is 7, 8, 9 comes here as it is like this. Okay, now we say T is a transpose of matrix A. Okay, so this is how you find the transpose of a matrix. In the second example, we are given the matrix B, which is a rectangular matrix of dimension 2 cross 3. So if 2 cross 3 is the dimension of the original matrix, transpose matrix would be of dimension 3 cross 2 because rows and columns are interchanged. So the row size of the first matrix or the original matrix would be the column size of the transpose matrix. Okay, so if this is M cross N, here it would be of dimension N cross M. Okay, so here M, the row size or number of rows is 2, so here number of columns would be 2, and in the original matrix the number of columns is 3, so therefore number of rows in the transpose matrix would be 3. So if it is of 2 cross 3 dimension, the transpose matrix would be of dimension 3 cross 2. Now what you do here is, first of all, let's catch hold of the first column and let's try to put that in the row in the transpose matrix. So I'll catch hold of the first column of the matrix, so I'll get the values 1, 4. So I'll have to place this first column values in the first row of the transpose matrix. So 1, 4 comes here like this. Okay, now you move to the second column of the original matrix B, then you will paste that in the second row of the transpose matrix. So here you will get the values 2 and 5. Finally you will move on to the last column of the original matrix 3, 6, that will be copied to the final row of the transpose matrix. So 3, 6 comes here, right? So you can actually create the transpose by actually interchanging the row into column or by interchanging the column into row. This is the transpose of a given matrix. Now let us devise our own logic to find the transpose of a given matrix. Given the original matrix A, here A is given of dimension 2 cross 3. So if the original matrix A is of dimension M cross N, where M is the number of rows and N is the number of columns, the transpose of this matrix, let's say T, would be of dimension N cross M, right? So in this example you have 2 cross 3, the dimension of the matrix A, so the dimension of the transpose of the matrix would be 3 cross 2. So you'll have 3 rows and 2 columns. Okay, so first let's try to fill up this transpose matrix row by row. So first we'll go to the row 0, right? Row index 0. So I'm at row 0. So what is the value that will be placed at T00? What is the value coming at row 0, column 0, this place, right? The value that's going to come here is nothing but the value from the first column of the original matrix. So in the row I'll copy the column. So the first value is the 8, A00, right? So I'll copy A00, which is 8, right? I'll copy 8 here. Okay, now what is T01? T01 is nothing but A10, right? A10 that is A10 is nothing but 0. 0 will be copied here, right? So this is how you can copy elements in row 0. Now once row 0 is done, we'll move to row 1. So in the row 1, this is index 1, row index is 1. What is T10? T10 is nothing but, I'll move to the second column of the original matrix. I'll copy the value A01. Okay, so T10 is A01. Okay, so what is A01? First of all, A01 is 6. 6 comes here, right? So what is T11? T11, this one is nothing but this value 7, right? That is A11. T11 is A11. So first of all, let's copy A11 here. A11 was 7, so 7 is copied here. Now we'll move to the last row of the transpose matrix. So this is row index 2. So I'm at the last row, row 2. Okay. In row 2, I'll copy the values from this column, right? So what is T20? T20, what comes here is nothing but A02. A02 would be copied in T20. So A02 is 3. 3 comes here. And then finally, what is T21? T21, this place, what comes up is nothing but A12. What is A12? A12 is the last value 9. So 9 comes here, right? So what I'm doing is I'm actually copying it row by row. First, I go to row 0 of the transpose matrix. I'll copy the entire first column or this column values in that particular row. Then I'll go to row 1 of the transpose matrix. There I'll copy these two values 6 and 7. Okay, then I'll move on to row 2, right? In row 2 here I'll copy the values. Now if you look here, there is a pattern coming here, right? In the transpose matrix T, what will you copy at index I and index J? Okay, it's very simple. At index 10, you are copying the original matrix index value 01. Okay, at index 01 of the transpose matrix, you are copying the value from the index 10 of the original matrix, right? At index 11 of the transpose matrix, you are copying the value 11. So if you see, at index Tij, you are copying the value from the original matrix of index Ji. That means row and column is interchanged, right? So whenever I is 0 and J is 1, see, I is 0, J is 1, this case I is 0, J is 1. Look at what is the index, row index of A, right? So row index of A is 1 and this is 0. So this becomes J and this becomes I. Okay, this is how you are copying. So this is the main logic behind the transpose of a matrix. Okay, now let's try to write a code for this. So first of all, if you are given the matrix A of dimension m cross n, m number of rows, n number of columns, this is my original matrix. If this is my original matrix, okay, what is the dimension for your transpose matrix? So let's say T is the transpose matrix. The dimension would be n number of rows and m number of columns. So this is my transpose matrix. Okay, now we are going to write a loop to actually find out our transpose matrix. Now we are actually trying to run a loop here, right? So here you see there are 3 number of rows and 2 number of columns, right? So first I'll run a loop for taking care of rows. So let's say I is the loop for taking care of rows. I equals to 0, right? I less than the size of the row. Size of the row here is 3. Okay, 3 I plus plus. Okay, and here now I'll have the loop, inner loop for taking care of the column. J starts from 0 and goes up to less than 2, right? Number of columns is 2, so it'll go less than 2 J plus plus. Okay, now this is the inner loop that will take care of the column. Okay, now let us try to make this code more generic. Okay, if you look at this original matrix A, you have 2 number of rows, so m is 2, number of rows is 2, and n number of columns is 3. Okay, and in the transpose matrix the row and column size is interchanged. Okay, so this is nothing but the row of the transpose matrix. This 3 is nothing but the row of the transpose matrix. So what is the row of the transpose matrix? So row of the transpose matrix is the column of the original matrix. So what is the column size of the original matrix? Column size of the original matrix was 3, which is n. So I'll write down n here. And what is the column size of the transpose matrix? Column size of the transpose matrix is nothing but the row size of the original matrix. Row size of the original matrix was M, which is 2. So here I'll write M. Okay. So if M cross N is the dimension of the original matrix, so this outer loop will run up to N and the inner loop will run up to M. Now inside this inner loop you are actually going to copy the values. Okay, so I'm going to copy the value in my transpose matrix T at index I and J. Okay, at index ij, what value do I copy? I'll just copy the value from the original matrix A. Whatever value is there at index J and index I will be copied in the transpose matrix in the index I and J. That is, if I have to copy the value A01, okay, where does this value go? It will go in the index T10. Okay, so if this is ij, this will be ji. Okay, so this is the logic for finding the transpose of a given matrix. Okay, now we are going to write our own function to find the transpose of a given matrix. So let's get started. So this is a program transpose.c to find the transpose of a given matrix. Okay, in this program there is a main function which is actually defining an array A. A is the name of the array. There are 10 rows and 10 columns in this array, maximum capacity 10 rows and 10 columns. Some of the variables for taking care of the row size, the column size, and the row and column index I and j. Okay, here I take the size of the array, and this is where I input my 2D array, and this is the code for displaying my 2D array in a matrix form. Now let's try to put this code in a function, right? So let's cut this code here. Now I'm going to write a function here at the top before the main function to display my array in a matrix form. So because I'm displaying the array, so return type is void. Okay, let the name of the function be display matrix. Okay, now what is the argument for this particular function? What is the input? Because if I have to display the matrix or the array in a matrix form, I need the array first, right? So let's say the array is mat, meaning matrix. Okay, so row and column size. Okay, and comma, because it's a 2D array, so I have to give two subscript, row and column. Okay, and then comma, what is the number of rows? Number of rows, let it be called as m. Number of columns, let it be called as n. Okay, so I'll just paste the code that I had copied before. Okay, here if you see, instead of a, I have to change this a to mat because name of my matrix or my 2D array is mat. I have to also declare variables I and j for running this loop, okay, in this function. And instead of rows, I'll write m because m is my number of rows and n is my number of columns. Okay, and this is my code for displaying the array in the matrix form. Okay, 2D array in a matrix form. So here we are trying to learn how we can actually pass a 2D array as an argument in a function. Okay, let's try to call this display matrix from the main function. So to display the matrix, let me write it here, display matrix. Okay, name of the array here, the array name is a, so I'm trying to display a, so I just give the name of the array. Whenever you are making a function call, you just give the name of the array. And number of rows in this particular array is rows, and number of columns is cols. Okay, and then just give a semicolon. Here I'll just write printf your matrix is, I'm just giving this message. Okay, I'm calling this display matrix function to display my matrix. Now let's try to compile this code and see what happens. Okay, so the compilation is done. It is giving me some errors, right? It is saying at line number 33 there is an error. If I go to line number 33, it is saying type of formal parameters 1 is incomplete. Okay, if you look at this, and you're also getting the error at line number 5. Line number 5 is nothing but this one, right? So whenever you're actually giving the argument here, this is the argument here, a matrix argument or the 2D array argument, you have to always provide the dimension of the column. That's compulsory, right? So here I have not provided the dimension of the column, so I have to provide the dimension of the column. In my array, the original array, the column size is 10, so therefore I have to provide this column dimension 10 here in the second subscript. I could also provide the row dimension, that is 10, but that is not absolutely required, so I can skip writing this. Okay, so now let's see, compile this code and see if it works fine. Compile it. So now you see all the errors are gone, right? So you need to understand, whenever you are giving the array as the argument in a function, you have to make sure that the column size is mentioned, right? So once the comparison is done, let's try to run this code. Number of rows and number of columns, 2 rows, 3 columns, values 1 2 3 4 5 6, and see, your matrix is being printed. This matrix is being printed by the function display matrix. Okay, now our main motive was to find the transpose of a given matrix. So let's try to write one more function to find the transpose of a given matrix. So let's try the return type is void. We are going to display the transpose of a given matrix from this function itself. So I'll write transpose. Okay, so what is the argument for this is the array, because I need an array to find the transpose, right? So the first argument is the array. Let's say the array name is A. So this is my array. I have to give the column dimension, right? And then obviously the row size and the column size. Let's say m is the number of rows and n is the number of columns. Okay, so in the original matrix, I'll write down here, in the original matrix A, number of rows is nothing but m and number of columns is nothing but n. That's given here as an argument. Okay, now first thing first, I'll have to create one array. Let's say transpose array T of dimension 10 10, right? So this is a transpose matrix T. Okay, now I also need to have a variable for running a loop ij. So I need one loop, outer loop, to take care of number of rows in the transpose matrix. Okay, so I equals to 0, I less than how many rows are there in the transpose matrix? Number of rows in the transpose matrix, I'll write number of rows in transpose matrix is nothing but number of columns in the original matrix. Okay, so first outer loop is taking care of number of rows in the transpose matrix. So number of rows is nothing but number of columns in the original matrix. Number of columns in the original matrix is nothing but n. So this will run up to n, and then this is I plus plus. Okay, this will take care of all the rows. Now here I'll write the inner loop that will take care of number of columns. Okay, for j equals to 0, number of columns would be number of rows of the original matrix. Number of rows of the original matrix is m, so j less than m, j plus plus. Okay, so we already devised this logic. Okay, I'm just writing it as a code here. Transpose matrix T at the index ij, the value at the index ij would be nothing but from the original matrix A, the value at the index j I. Okay, this is the logic. Okay, so if once this logic is done, the transpose is created. T is the transpose. Now I need to display the transpose matrix. Now I can easily use the function that we have already defined to display the matrix here, right? If that display matrix function is not there, I need to write the entire code for displaying the matrix. So whatever is being repeated multiple times, you have put that in a function. So display matrix I'll call here display matrix. Which matrix I'm trying to display? Transpose matrix, right? What is the number of rows in the transpose matrix? Number of rows is n and number of columns is m, right? We have already discussed that. So here I'll just write printf transpose matrix is, okay, so this is the displaying of the message transpose matrix is, and I display the transpose of a matrix. Okay, so let's try to compile this code, but before I compile I need to obviously make a function call to transpose, right? So I'll make a function call to transpose from this particular main function, right? So here I already have this message printed here, that is your original matrix is this one, and then I'll just print one more message, your transpose matrix message I need to print, but that's already being printed here, right? In the transpose, this is already being printed here, so I did not print it one more time. I just make a call to the transpose function, transpose, right? What I'm trying to transpose, I'm trying to transpose the array A. What is the number of rows in array A? Rows is the number of rows in the array A, and COL is the number of columns in the array A. Okay, so this is a function call. One thing that you need to remember here in this function call is that whenever you are calling or passing the array as an argument, whether it's a 1D array or a 2D array or a 3D array, you just give the array name here whenever you are making a function call. Okay, so let's try to compile this code and then see if it works fine. Okay, so it is saying that transpose is not identified. Maybe the name of the function is not correctly written down here. So this is transpose. Okay, so this is TRANS. Function name should be correct, transpose, right? So let's compile it one more time and then see if it works fine. So now there is no error, right? So let's try to run this code. Number of rows and number of columns, 2 rows, 3 columns, values are 1, 2, 3, 4, 5, 6, right? This is the original matrix and this is the transpose. You see the row here has become the column here, and this row has become the second column, right? I can give any other matrix, let's say 4 plus 4, I give the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, right? So if you just look at this, it is being transposed. 1 2 3 4 here was the row, in the transpose 1 2 3 4 is the column, right? And if you see 15 16 17 18 is the last row, and that is the last column in the transpose matrix. So this works really fine. Now we can do a little bit more improvement in this program, right? If you see here, my array original matrix has the maximum capacity of 10 rows and 10 columns, right? I can actually define these constants as my symbolic constant. So what I do at the top is I can just write has define, right? My maximum size is 10, max is 10. So instead of writing 10, wherever 10 is there, I can now write max. Wherever 10 is there, I can go and write it as max. Now this makes things simpler, right? And whenever if you need to modify this, okay, you can modify it as many times as you want, and you can modify it easily just by changing the value of max at the top. We have already studied symbolic constant, right? Now let's say if you'd like to have the maximum size as 8, so you just need to make changes here at one place. It will be affected everywhere where max is appearing, right? So here I'm getting this warning. The warning is, it is telling me that, okay, originally you need to actually use 8 because the matrix is 8, right? But sometime I'm using 10, right? So if you just look at this transpose function here, if it is max, I need to make this also as max, right? Otherwise it will be a mismatch, so it may not work well. So this kind of warning may come, right? But now if I do it, compilation is successful, and I write 2 3 1 2 3 4 5 6, okay, and it is working fine. Okay, so using symbolic constant, you can actually define the size of the matrix. The maximum size that you have allocated for your matrix can be done using a symbolic constant like this. Okay, so if you do this, you can just have to make changes one time, and it will be reflected everywhere the max is appearing. Okay, so this is how transpose of a matrix works. So in this video, in this lecture, we have learned the logic behind the transpose of a matrix, and then we have learned what actually is a transpose of a matrix, right? And then we have implemented the transpose of a matrix by writing a function, and then we have finally learned how we can pass the 2D array as an argument in a function. Okay, so that's all in this lecture. Stay tuned.